Lab 3, black hole. So the purpose of this lab is to first analyze the motion of a star and use that to calculate the mass of the black hole it is orbiting. Then take this information and use it to calculate the velocity of a spaceship that must take off from a planet near the black hole in order to escape the system without crashing. And in this case, or for this lab, the star is the system. So a quick preview of my results. I got the mass of the block to be 9.64691 times 10 to the 33 kilograms. And I got the ship's initial velocity to be this vector right here. So the fundamental physics principles that I use in this lab are Newton's second law, which is the momentum principle. It states that the net force is equal to the mass of an object multiplied by its acceleration, or the change in momentum over change in time. And I also use the law of universal gravitation, which is right here, and then the velocity and position update formulas, which are right here. So part one, this is my glow script model. I obviously had to calculate the initial velocity, final velocity, and then initial and final momentum, delta v, delta p. So these are all my variables that I use for my calculations. And here are my results. So I found the net force on the star to be equal to 8.24731 times 10 to the 28 newtons. This is the parallel component, and this is the perpendicular component. And then right here you can see, once again, the mass of the black hole that I calculated. So here's my glow script model for part 2. Here are all of my variables that I had to calculate. So like planet velocity and position, ship velocity, and then the radius between planet, ship, planet, black hole. And then here are my other calculations. So my ship speed. And then here are my results for part 2. So I found that the initial velocity of my spaceship was this vector right here, negative 5.04 times 10 to the 7th in the x, and 7.83 times 10 to the 6th in the y. And here is my the result from my computational model that shows the trajectory of the spaceship here in pink, and the orbit of the planet in blue. So potential errors in my lab, one potential source of error is with the initial velocity of the spaceship. Since I used trial and error, there could have been a different initial velocity that would have gotten the spaceship maybe a little bit closer to the black hole and still escape. And then another potential error could be the time interval I used for my calculations could have been slightly wrong. And the third potential error is that since this is only a model and not actual reality, it might not be 100% accurate. There could be slight errors in the model. So my what does it mean question? How are the net force and its perpendicular and parallel components different from the rate of change of momentum and its parallel and perpendicular components? So net force and change of momentum over change of time are actually the same mathematically, but calculating change of momentum is much easier than calculating net force, because calculating net force includes summing all forces acting on a system, which obviously includes the black hole in this case, but could include maybe some other things. Versus, calculating change of momentum can be used by just looking at the star. And my what if question, what x speed in the x and y I would need in order for the ship to reach orbital velocity, I calculated it to be negative 1.75 times 10 to the 6th in the x and 6.27 times 10 to the 6th in the y.